the Algebra 1 Unit 5 review. So just going to go through our 15 slides here, and really this just kind of summarizes everything that's in this unit. If you got bigger questions, come and let me know during asynchronous time, or else just send me a message Canvas inbox. Alright, let's get prepared for our test Thursday/Friday. Okay, so here we see a table where it says input and output. So remember, input is the same thing as the x values or the domain, and the output is the same thing for the y values or the range. They're really just synonyms. So here it says, is the relation a function? So here the answer would be no. So why is this relation not a function? Well, we have an input of 4 that gives us an output of 7, but we also have an input of 4 that gives us an output of 14. So you have the same x value of 4 that gives you different y values. And if that happens, that makes it not a function. Okay? Alright, so now let's look at the same type of question but from a graph. So here, is this a function? So the answer is yes. So why? Well, if I look at all these x values, like the x value at this point is -3, here it's -2, here it's +1, here it's +2, here it's +5. So the x values do not repeat. And since the x values don't repeat, then it has to be a function, because there's no way we have the same x giving us different y's if we never have the same x to begin with. Okay? You can also think about this as the vertical line. If I drew a vertical line through each of these points, they would never cross through another point. Alright, so now let's just do it from a set of coordinate points, but we don't have a table here. Okay? So now we're looking, is this a function? So yes. Again, why? Well, what are the x values? 4, 3, 0, and -7. So the x values do not repeat. Okay? Alright, last one for just looking at it, is it a function? So is this a function? So the answer here is no. So why? Well, if I drew a vertical line, it would cross the graph more than once. So specifically here, it crossed twice. So since it crosses the graph more than once, it's not a function. So you could say that it is not a function because a vertical line crosses the graph more than once. If we wanted to be more kind of math terminology, we could say that it would fail the vertical line test. And what that really means is if we drew a vertical line, it would cross more than one time. Okay? Alright, so now let's look at this. Now let's identify domain and range. So here we see this is what's called a non-continuous function, meaning that the lines do not connect and it doesn't extend. Okay, there's no line here, it's just a bunch of points. Alright, so is this relation a function? Well, let's look. See these? They have the same x values, but they have different y values. So if we drew a vertical line, it would cross through both of those. So this answer would be no. Now let's answer what the domain is. So the domain are all of the x values. Remember, x goes left and right. So basically, we're just looking for what are the x values for these different coordinate points. So this x value is at -5, so I'm going to write -5. Both of these x values are at -4, so I'm going to write that. This has an x value of 0, so I'm going to write that. This has an x value of 1. And lastly, this has an x value of 3. Alright, so what's the range? Well, here you go. This is at -5, so I'm going to write -5. This is at -4, so I'll write -4. This is at 2, so I'll write 2. Both of these points have a y value of 3. And then this point has a y value of 6. So again, I've written down the domain and the range values just as individual points because there's no line here. So they're just those values, okay? And notice when we had the same value more than once, I only wrote it one time, and I did write them from least to greatest, okay? Alright, so now what's the domain and the range here? So first off, is this a function? No. If I drew a vertical line, it's going to cross more than one time, so it fails the vertical line test. So that one hopefully is pretty easy to say no. So what's the domain? So now we can't just list a bunch of points because we have a line. However, it's not going to go to positive or negative infinity because we don't see any arrows. Okay, so we want to say what's the lowest x value? Well, here it is. So what's that at? This edge of the circle is at -2. So we're going to say it goes from -2 to the highest part of the circle for x. So we go all the way to the right, which takes us to here. What's that at? That's at 10. So from -2 to 10. So that would tell us that the domain is from -2 to 10 inclusive, meaning it could be -2, it could be 10, it could be everything in between those numbers. Okay? You can write it like this. You can also write it as an inequality, so I'll show that when we do the range here. So now For the range, I do the same thing. What's this lowest value? Well, that lowest value is at -1, -2, -3, which would be like this point right there. So we're going to say it goes from -3, and then I'm going to hit my keyboard here to say less than or equal to y, because we're talking about range, which is less than or equal to. Now what's the highest y value? Well, there it is. It's at 9, so all the way to 9. Okay? Now keep in mind, I could write this the way I wrote the domain. I could write the domain the way I wrote the range. I would just say -2 is less than or equal to x, which is less than or equal to 10. And down at the bottom, I would put bracket -3 to 9 bracket. Okay? All right, so now let's look at it where we actually see a line. So first, let's do the simple part. Is this a function? Yes. I draw a vertical line. It would only cross one time. So it would pass the vertical line test. So now, the domain, the range. Actually, this one should be the easiest of the continuous functions because there's an arrow here and an arrow here. So this graph goes left forever and right forever. It also goes down forever and up forever. So the domain and the range are really everything. So you can write the words all real numbers, or if you prefer, you can write it with the negative infinity to positive infinity. Okay? So that works also. Again, it went left forever, right forever, down forever, up forever. Okay. Screen 8 here. So again, is this a function? Yes, a vertical line would only cross one time. What's the domain? So again, left and right. Well, this goes left forever. This goes right forever. So the domain, again, is all real numbers. Or, again, you can write negative infinity to positive infinity. Now let's talk about the range. So I know the range can't just be all real numbers because there's no arrow that goes down off the graph. They go up off the graph. So I need to identify my lowest value, which is right here at that point. So then I say, well, what's that for y? What's it, -1, -2, -3? So a couple ways to write it. You can just write y is greater than or equal to -3. That is an absolutely fine answer. You could also do it with the parentheses and the bracket. So we'd say bracket inclusive because it includes -3. That is a point on the line. And the arrows go up forever. So you would say it goes to infinity with a parenthesis because that's not inclusive because you can't actually get to infinity. So this is where the graph opened up. So then we are going up to infinity. So now let's look at screen 9. Now, this is a function. Draw a vertical line, only crosses one time. What's the domain? Well, again, it's every number here goes all the way to the left forever. Every number here goes all the way to the right forever. So again, it could be all real numbers, or you could write negative infinity to positive infinity. Okay, what's the range? Well, now, since the graph goes down forever, they go down to negative infinity, but it goes up only to 5. So you'd say it's everything from 5 and below. So you could write that as an inequality. Y is less than or equal to 5. That would be a totally fine answer. If you wanted to get more fancy and write it in interval notation, we'd say it goes from negative infinity to 5 bracket because it's inclusive of the 5 because that is a point on the graph. Okay? Alright, awesome. Alright, so now let's get to writing this in function notation. So you really just need to understand the difference between these two setups. So this says g of 4. When you see g of 4, that means when x is 4, so go to where x is 4, what is the y value? And remember, y is the same implication as f of x or g of x. It means as a result of x. Okay, and the y value is always as a result of x. So here it's saying when the x value is 4 in this table, what do you get for the y value, which is g of x? So it's 16, so I'm just going to type a 16 in here. I didn't have to calculate anything. Now here it's in reverse. It says g of x is 25. So in the g of x column, I'm going to find the 25. Well, what's the x? Oh, it's 5. Boom. Okay? All right, so that was from a table. So now let's look at it from a set of points. So find f of -3. Well, here's -3 for x. Well, what's the y value? It's 27, so I'm going to write my 27 in. Okay, here it says find x if f of x is 8. So if f of x is 8, here's that. Then what is x? Oh, it's -2. So I'm going to write x is -2. So there you go. Okay? So same thing. This setup, f of a number, means when x is this, what is y? This setup, f of x is a number, means if y is this, what's x? All right, now let's do it where we actually have to work out an equation. So here it says, what's g of 2? So remember, we see this set up. This means when x is 2. Just put the 2 in wherever you see an x here. So here we go. I'll write it out for us. G of 2 equals 8 times 2 minus 6. Okay, well, g of 2 equals, well, 8 times 2 is 16, minus 6, 16 minus 6 is 10. G of 2 equals 10. Okay, so g of 2 equals 10. Alright, g of x equals 26. Well now, where is the g of x? It's on the left-hand side. So I'm going to write it where I see the g of x. So I'm going to put 26 equals 8x minus 6. Alright, well now I'm going to add 6 to both sides. I do that, and I get 32 equals 8x. I'm going to divide by 8 on both sides. And 32 divided by 8 equals 4. So it's telling me if the answer was 26, then I had to have put a 4 in. So that would mean x is 4. Okay? Alright, and then lastly for these types, let's look at it from a graph. So what is f of 1? That means when x is 1, what's y? So I go to where x is 1. Well, where's that on the graph? Oh, it's right there. So what's that y value? Well, it's at 1, 2, 3. Great, there we go, 3. Okay, so now it says find x. So now I'm trying to determine what x is. If f of x is negative 6, remember this means when y is negative 6. So I go to where y is negative 6. Okay, here we go. Boom. There's my point. So now I just say, well, what's that x value? Oh, well, it's 1, 2, 3, 4. Done. So x is 4. So again, the top one's saying, if x is 1, what's y on the graph? The bottom one's saying, if y is negative 6, what's x? Alright, and now let's go to interpreting these graphs. So the top two scenarios should be pretty simple for you. What do the x values represent? Well, just read the graph on the x-axis, right? So it represents your time in seconds. What do the y values represent? Well, again, it's just written right here, so it's your distance from home in meters. And then you have to actually think about it for the explain your graph. So what happens here? Well, after no seconds, this person's at home. So the person is at home. Then from 0 to 50, everybody see how it stops at 50 seconds, they walk. Notice how far they are from home, 100 meters. They walk 100 meters away from home. So that takes us from here to here, right? Because it's at 50 seconds, they've walked 100 meters away. So now from 50 to 70 seconds, from seconds 50 to 70, they walk back toward home. Okay, so they walk back from here to here, and now they're only 40 meters away from home. They walk back toward home, so they are only 40 meters from home. Lastly, so now what happens? From 70 seconds to 100 seconds, from 70 to 100 seconds, they walk away from home. And then how far away from home do they end up? At 160 meters, right? So they walk away from home all the way to 160 meters. Okay? Alright, so now let's think about it one more time with a different scenario. Here it's talking about cost of renting a car. So again, let's knock out the two that we should know. What do the x values represent? Oh, it's the miles driven. Now notice this part. Miles driven over 150. Okay, so it's your miles driven beyond 150. So after 150. What do the y values represent? Total cost in dollars. Okay, so it's our cost in dollars. All right. So what the heck is happening in the graph? Okay, so this says our excuse me, our cost in dollars. Well, this is in between 30 and 35, so let's just say it's 32. So you pay $32 to, and what are we doing? We're renting a car. To rent a car. Now, when this is at 32, this is for what? The miles to 150. So you pay $32 to rent a car for the first 150 miles driven, right? And then what happens? After you drive more than 150 miles, don't you pay a little bit more? So then you pay more for every mile driven after that, okay? And it constantly goes up, right? So if we've driven an extra 25 miles beyond the 150, well, now where's my point? It's about 38, right? We paid an extra $5 or whatever, right? All right, but that would be enough to suffice. Okay, so here's your summary for the test review for Unit 5. Hope this helps. Let me know if you have questions.